In this video, we are just going to do an example and see how to apply the longitude and the latitude. I don't know why I say longitude. Okay, we're going to apply the longitude and the latitude to a given situation. We are told that Wits has latitude. Wits has a latitude of 26.5 degrees south and longitude 27 degrees east. Now this example at least will explain some of the things that we couldn't explain in the previous video. The latitude is usually stated as either south or north because it will tell you the hemisphere where this particular place is. We are told that it's S, so it means it's in the southern hemisphere. And then the longitude is measured as 27 degrees east. It means it's measured 27 degrees to the east side. By convention, usually degrees are measured in the east, but if you're given west here, don't be confused and try to go through east. Rather go the other way through west instead of through east. But normally by convention, if you're just given longitude as 27 degrees, you measure it through east. But here we are given the direction, so let's use that direction. And here we are lucky because at least our direction is just east. So you draw the celestial equator like this. This is just the celestial equator, right? This is our center, and the celestial equator goes at the back like this. And draw your y-axis or the Greenwich meridian, and this is going to be our north celestial pole or south celestial pole. If you want to get full marks, draw it the same way I'm drawing it. If you draw it the same way I'm drawing it, you get your full marks. This one will be O. This one will be O. That is the what? That is the center, the core of the earth. That is the core of the earth. No. This is not C. This is not O. This is C. I don't know what Houston is doing here. He's writing O where this is O at the what? At the origin. I was writing O where it's not supposed to be. So this is going to be C, right? This is going to be our O, our origin, and that is our core of the earth, our center. We are told that the longitude is better starting with the longitude, because it is the longitude will pick up the meridian, because the meridian is what we start with. So let's start with the longitude. The longitude is 27 degrees east. So we need a meridian that will cut at a point M that makes this angle OCM 27 degrees. Since OCM measures what? Well, measures longitude. So this OCM has to be 26 degrees east, going in the easterly direction. So since this is going to be our east, this is going to be our west. So coming in the east towards the easterly direction like this, we should measure an angle of 27. So I'm just going to put my M here so that this angle OCM is 27 degrees. So this angle here is 27 degrees. I've said that this angle is going to be 27 degrees because that is our OCM. And now I know where my meridian is going to cut, so I can draw it in. So this is the meridian of the point. This is the meridian of Wits, and it cuts through M. So I just drew a great circle that passes through point M, going to the south celestial pole like that. The other thing now that we need is the latitude, because we need to know where exactly is it lying on this meridian. So it's best starting with the longitude, then going to the latitude. So on the latitude it's saying 27.5 or 27.5 degrees south. What does that mean? This south means it's not in the northern hemisphere. It means it's in the southern hemisphere. So it lies anywhere here after M. This is the equator, right? So starting from M going down here, that's where our what? Our southern hemisphere is. So this is going to be our southern hemisphere. From the equator going all the way down to the south celestial pole, south geographical. Forgive me for putting NCP. Please forgive me because I was totally wrong. It's going to be NGP and SGP, not NCP. That was totally wrong. Some people picked it up already, and they were laughing. That guy Houston, what is he writing there? But yeah, this is the way it's supposed to be. So this is the southern hemisphere. So we need to know 26 and a half degrees south. It basically means from the equator dipping downwards. the southern direction, dipping downwards, you should dip 27 degrees. In our previous example that we did, when we were defining this, we were looking up to a point P, so we were elevating our eyes, and then we had MCP, so it was an elevation. But here it's in the southern hemisphere, so it's a dip. We are going to what? To look downwards to a point P. It's going to be somewhere here, and we're going to do MC, and the P is going to go downwards. It's going to go downwards. It's going to be MCP going downwards towards the south geographical pole. It's going to be a dip downwards. So I think for you to nicely see this diagram, let me draw a larger one for you to see. This is going to be our equator, goes at the back, and then this is going to be our Greenwich meridian, goes from the north geographical pole all the way to the south geographical pole. And I said this is going to be our core, and this is our origin. So for the longitude, OCM is supposed to be 27 degrees east, towards the easterly direction, isn't it? So I said our M can be put there to make sure that our OCM makes an angle of 27 degrees here. Makes an angle of 27 degrees flat on the equator. And then now that we know where our meridian cuts for Wits, this is going to be the meridian for Wits. It's going to be like this. That is the meridian that cuts through Wits. That is the meridian. But now we need to know where Wits lies. Does it lie on this part of the meridian in the northern hemisphere, or it lies in this part of the meridian in the southern hemisphere? And the equator is the one that separates the northern part, which is above the equator, and the southern part, which is below. So it's going to be south, because we are told that it's what, 26.5 degrees S. This S gives us the signal that it is southern hemisphere. So it's going to lie somewhere down here. But where it's lying, I can put it here to make sure that my angle MC to P, when I go down, when I dip down, this angle here will be 26.5 degrees. And it's south because it's towards the southern geographical pole. So that is how you can draw your diagram. It's so easy. If you're given that it's 26 degrees north, you would have put maybe the point there, and then this MCP would have been something like this, with 26 degrees north going up towards the northern hemisphere, like that. So that is a simple example. But now there's an important concept. Angles. Here we're dealing with a sphere, right? Since the Earth rotates uniformly about its axis from west to east, when it rotates, it makes one rotation in 24 hours. It means one rotation. Let's say one rotation is equal to 24 hours, right? So what this basically means is one rotation is 360 degrees. Therefore, 360 degrees can be likened to 24 hours. So when it goes right through 360 degrees, one rotation, it takes 24 hours. So these two should be representing the same thing. So sometimes you might not be given degrees. You might be given in time format. It is the same thing. We just need to see the relationship. This is going to be one relationship. 360 as to 24 hours. If you want, you can divide both sides by 24. So if I divide both sides by 24, this is what I get. So this was one relationship, 360 to 24 hours. And if I divide by 24, I'll get another relationship, 15 degrees as to 1 hour. That is another relationship here. If this basically means 15 degrees is equal to 60 minutes. It's the same thing, because 1 hour there are 60 minutes. So this is another relationship, though these two are just representing the same thing. Then we can divide both sides by 15, which means 1 degree is equal to 4 minutes. That's what it basically means. So this is another relationship, And then since this is another relationship, We can keep going, dividing and dividing and dividing. This 1 degree is divided because for time we know the minutes, but for degrees there are things called minutes as well, and they are represented like this. In 1 degree there are 60 minutes. You put a dash like that, that represents minutes. So basically in this 1 degree there are 60 minutes. So these 60 angle minutes are equal to 4 time minutes. So 60 angle minutes are equal to 4 time minutes. This is another relationship, though they are representing the same thing. These two are representing the same thing. So with this new one, we can divide both sides by 4. It means 15 arc minutes. They're actually called arc minutes, not angle minutes, but they're called arc minutes. 15 arc minutes is they are equal to 1 time minute. So this is a new relationship. So 15 arc minutes are equal to 1 minute. Let's do it again. 15 arc minutes are equal to, what is 1 minute? 1 minute is made up of 60 seconds. So this is another relationship. These two are related. We are at this point now. So we can divide by 15 to get 1 arc minute will be equal to 4 seconds. 1 arc minute is equal to 4 times seconds. It's equal to 4 times seconds with an S representing the second. 1 arc minute equal to 4 times seconds. But we know that 1 arc minute is equal to 60 arc seconds, and arc seconds are represented by 2 dashes. Those are arc seconds. Arc representing an angle. So these are angle minutes. They are equal to 4 seconds. So this one was a new relationship which is related to this one. So it's going to be in those two. We can go further and divide by 4. And dividing by 4 gives us 15 arc seconds are equal to 1 time second. 1 time second. This can be our final relationship. So these relationships are going to be very important. I think we'll do in the next video. We're just going to do, let's see, should I do that in the next video? I think it's better doing the next video because it's going to be a bit of explanation of how to convert from degrees to time, or from time to degrees. It's just going to be, I think, a 10-minute video just to see how best to do that. So stay tuned for that video that's coming up.